why do we need a framework like Spring? Okay, I think many of you are already use the Spring framework for a long time, and some of you are exposed for a few years. Just wanted to get your opinion. Why do you need a framework like Spring? Why do you need?
So in my opinion, it is more like a disciplined way of developing an enterprise application, a more disciplined. Spring brings in that discipline into your application development. That
Can
is
you
my,
can you please elaborate what do you mean by discipline?
So what happens is, uh, you know, not only Spring, most of the frameworks rather, but Spring specifically is, it by default brings in a lot of things like, the design patterns, like, whatever factory or abstract factory, whatever design pattern it brings into the code. That's number one. And it tries to streamline or bring up a development environment where applications have a convention to talk with different components. Instead, what happens is, on the other hand, it becomes messy. Interaction between the components becomes too messy and not manageable. So manageability, one of the primary factor.
Okay, got it. Anybody else? Why do you need a Spring framework like Spring?
Uh, I feel Spring is a great framework which gives a capability around it has more wrapper classes around every functionality that the Java developer needs, and it actually removes the coding which developers need to take care of. So I think that's the way Spring is doing it.
Okay, got it. Anything else?
Yeah, Manju. One more thing, the Spring takes care of is it overtakes the control of object creation to itself. As there are many other frameworks, Spring also provides that feature that we can do constructor injection or setter injection, and it overtakes or controls the object creation to deletion. All is taken care by Spring. We don't need to initialize the object every time. We just need to call the bean, and the bean will be initialized automatically by Spring.
Okay, got it. So that's why we need a Spring framework. Any other reason? What is actually goal of the Spring? Why do we need it? Anybody else? All right. So all the answers are good and valid. Okay. But actually, if you look at the primary goal of the Spring framework, okay, the goal of the Spring framework is actually for you to provide a very comprehensive infrastructural support for developing an enterprise Java applications. That means the lot of the plumbing code, okay, boilerplate code kind of things, you leave it to a framework. So you don't need to worry about plumbing code and boilerplate codes. Okay, let's a framework handles and deals with those kind of codes. Okay, when you given those kind of pain areas to a Spring framework, what you can do is you can actually focus on solving the domain problems. Okay, so as a developer, Java developer, you actually focus on solving the domain problems rather than dealing with the plumbing code and a lot of boilerplate codes. So all this will be taken care by a Spring. You don't need to worry, and you just focus on solving the domain problems. That is the actually goal of Spring. Okay, Spring framework. Like in order to achieve this goal of this Spring framework, okay, what Spring has done is like created a kind of core support, which is in the four categories. Okay, application configuration, and somebody has pointed out that I want an application where the object creation need to be done by some framework. Okay, and I wanted to integrate with an external interfaces like an enterprise integration. If I wanted to talk to a database, if I wanted to talk to sending a messages, okay, if I wanted to do an external things, Okay, so where I wanted to have a simplified way of dealing with an enterprise integration. Okay, so that's another core support. And when I build an applications, one of the critical part of the application is maintaining the quality. So how do I assure the quality of the applications? So one key thing is the way you build, the way it is supposed to be built, if you build an application based on certain principles and design rules, your application can be easily go and write a unit test cases, integration test cases and system integration test cases. So those kind of test cases you can actually go and write. When you write those test cases, every time like your code quality will be verified, validated by the testing part. So if you write the code in a way what Spring is expecting, you will be able to write those kind of test cases in a much better way and easy way. So that's part of the testing. Okay. There's another thing is like data access. So now we have so many data access technologies are there. Like you have a JDBC, you have a Hibernate, you have a JPA, and you have other kind of data access technologies are there. So now if I wanted to make it work, my application with the different technologies, okay, I want to have a uniform way of doing it. Okay, so like Spring actually provides, you don't worry about low level or data access technology underneath what you use. Okay, it will get kind of normalized. Doesn't matter whether you use JDBC, Hibernate, JPA, but you're still the core code is same. You don't need to change any of the code, the kind of things. Okay, so that is being provided by a data access module. Okay, so these are the few things what core supports to do it. So let's take how actually I can create an application configuration. Okay, if you take any B2B application, when the new B2B applications are, if you want to design, let's say I want to go and design one B2B application where orders and I want to process the orders and I want to dispatch the orders and I want to deliver the orders. If I have the B2B application need to be designed, the way I do it is, first thing is I will take those requirements and actually I will create a modules, like modules or components. Like first I'll go and create a module called like order modules. Okay, in the order modules, I'll take the orders and I will take all the line items what need to be put in that order. Okay, and there will be another component called like a dispatcher, let's say. Okay, so dispatcher is responsible for dispatching all this order to process it. Okay, so there is another component called customer where the customer details will be there. I want to whenever the order is created and I need to associate with the customer, so I will come up with a kind of different modules or different components when I design the enterprise applications. The first thing, now when I have these components designed, so tell me, how will you actually connect to different components? Let's say I have an order and customer and I have a dispatcher. How will you connect to this different components from your component? How will you connect these components?
Interface.
Good. So the way I connect is using an interface. That means the interface itself doesn't have any implementations. So I create an interfaces. Let's say here dispatcher. I go and create an dispatcher interfaces and I'll give it to other components to integrate with it. So this components is not really worried about anything specific to implementation specific. As long as I have an interface contract being unchanged, not disturbed, then component A well integrated with the component B. Okay, so all the implementation will go into a specific to that component. That's how I kind of like integrate this component A with component B using an interface. Okay, so what are we achieving here by using an interface? What are we achieving by having an
Kind
interface?
of a contract realization.
One is contract realizations. That means there is no changes in the APIs being provided, so that other component will work with and grace.
And each and every component can work in Xylo. So one component need not know about the other.
Right. When I say Xylo, so it is like independent and there is no dependency on actual implementations. So each component can behave well independently. Am I right?
Yeah. Yeah, correct.
Good. So that way, so you have a kind of loose coupling between the components, irrespective of an implementation, what they pick up to implement. They may implement in the native code or implement in a generic. They can do whatever they want. It is completely independent of an implementation. That's one thing we are achieving. Okay, so that is called as a loosely coupling. Okay, so the loosely coupling between two components can be accomplished here. Okay, so what I'm doing here is the way I connect these two applications. I made it as a loosely coupling by introducing a concept called an interface. I achieved this loosely coupled, and underneath I can go and implement any of the implementation, and that implementation get plugged or binded to the interface at the runtime to connect and invoke those operations to work with. So what I do is I take the same concept, I'll go into a little, into component level itself. If I'm writing a two classes, okay, let's take an example. Okay, I want to transfer money from one account to another account. Okay, the way I do is, let's say I have this transfer service facade class. Okay, a facade class is a service class. Okay, in the service class, I will have a method called a transfer method. Okay, inside the transfer method, I will have to put my business logic. What is my business logic? First thing, I have an account repository where this guy will deal with a database to load the accounts, let's say. Okay, so inside this, I'm going to put the business logic to do a transfer money from one account to another account. So in order to do that, first, what I need to do is I need to load an account 1 and account 2. Okay, so what I do is I load an account. There is a load account interface provided by account repository. Okay, I load it and create an account object and get the an instance of it, and same thing I do it for account 2. So now I have both the instance of accounts. What I do is I'll withdraw money from this account A1, I'll deposit into account 2. Okay, so debit and credit. So once I have done this, so what I need to do is I need to go and update these two account objects. Okay, update account 1 and update account 2. So once I am done with this account updates, then the whole transfer of money from one account to another account has been accomplished. Then I can say it's confirmed. So this is my business logic, and this is my facade class, and this is my repository. And if you look at this, the simple example, transfer service is a facade class, and account repository is another, which is connected to the database side. Okay, so let's say if I have this implementation, what do you think that how does this transfer service and account repositories are connected each other? Can you imagine the object A account repository is been created in the transfer service class, right?
Yes, Mani.
Yeah. So now if you look at, if you go and imagine like transfer service.java class contains the account repository object instance. Okay. So now, since it is binded closely together, and if I want to bring some other account repository, it is not possible unless I go and change the code in transfer service. Okay. So these two are initially, it's a tightly coupled. Okay. In order to make it as a loosely coupled, what I do is instead of having directly an implementation of this class, first I will make this as an interfaces. So what I do is transfer service I will make as an interface, account repository I will make it as an interface. Okay, I'll bind these two interfaces in an interface level. So transfer service have this account repository binding, not an implementation. Then once I have this interfaces, I will actually go and do an implementation. So implementation will be like transfer service impl.java. There I'll put this business logic. Okay, and I'll go and write a specific account repository implementation. Let's say JDBC account repository. Okay, JDBC account repository is an implementation of account repository interface. I'll go and put all the load implementation of this method into JDBC account repository. Now, if you look at the transfer service implementation and JDBC account repository are nowhere connected each other. They are connected through interfaces. Okay, at the runtime, I need to somehow these two guys need to be connected, like transfer service implementation and the JDBC account repository need to be connected. Okay, so the way I connect these two guys, transfer service implementation to this JDBC account repository, I will have to go and connect these guys at the runtime. I don't need to worry about connecting them at the compilation time. What I do is I'll just go and write a special method which is called set account repository in transfer service implementation. I'll go and create this JDBC account repository elsewhere, and I connect into this, into transfer service repository. So if you look at this kind of factory pattern, okay, the way I create and connected these two classes will be similar to your factory design pattern. So given this object, I wanted to, JDBC account repository to be created and connect to a transfer service implementation. Okay, so for that, either I need to go and write some additional class, I need to go and write the factory classes to create and connect with them. Okay, I need to do some other means of connecting these two guys. Okay, so that's a way these actual implementation will get connected. Okay, so what Spring offers here is, so you don't need to worry about connecting and writing a factory classes anymore. Okay, the Spring provides you to support to and assemble such an application system from its parts. Like you go and write these POJOs separately, independent of it, and connect them using an interfaces. So you can just go and create as you provide instructions to a Spring configuration. Say I wanted to create this object, connect together. Okay, so you don't need to worry about finding each other, whether who creates first, who creates next. You don't need to worry about it. That's a headache or a responsibility of the Spring configuration. Okay, that's first part. And second part is account repository, whatever we've seen, whether it is a JDBC account repository or Hibernate account repository or JPA account repository, doesn't matter. You can go and swap easily without even changing the code in the transfer service implementation. You can easily swap out the different implementation of it. That's an advantage you get. Okay, that's about the configuration, how you can provide. If you look at that configuration in the Spring, how the wiring will happen or connecting will happen. First, you will have a JDBC account repository. It's created, and this JDBC account repository need to be connect with a transfer service implementation. Okay, so you create this object first, and then you create this object, and this object need to be wired together. The way I wire is, I will assemble this, I'll inject this into a transfer service implementation. The way I create is actually like JDBC account repository. You create an instance and you create a transfer service implementation object, and this service.set account repository, you go and write this method and inject the repository and instance here, object instance. And at the runtime, I need to write this kind of piece of the code to get connected. Okay, so this is the concept called a dependency injection, the runtime. So dependent objects get injected the right place in the right order for the objects based on your instructions. This is one of the key concepts being used in the Spring. Okay, the concept is a dependency injection. All the dependent objects, whatever it is required for your object to be get injected before you start using it, you inject it and start using it. The concept called the dependency injection. So a dependent object gets injected through some other means. Okay. The way the code looks like if you look at this JDBC account repository, a JDBC account repository is an implementation of account repository, and you have a service class, service interface, and I have this transfer service implementation, which is the implementation of a transfer service interface. Now I have this transfer service has connected with an interface. Okay, so account repository object, and I have this set account repository where it takes this account repository as an object and set this to instance variable. Okay, so now if you look at this transfer service implementation and JDBC account repository, it doesn't know each other, where these guys connected using an interfaces. Okay, this is the dependent object that depends on the service interface. The concrete object will be get created on fly and injected to this transfer service implementation object, the runtime, and I can inject any kind of implementation of account repository and interface class. I can easily swap out. So now if you look at the way it swap out is, I have a transfer service implementation class object where I go and inject this JDBC account repository. Let's say I go on my development starts with a JDBC first. Okay, so once I have JDBC, everything works well. Let's say I have a requirement to move to JPA or Hibernate. Okay, so I don't go and change any code here. I'll just go and write an implementation of it, JPA or Hibernate account repository. I'll swap out. Only thing is my configuration to inject will be different. That's all it is. I don't need to worry about changing my actual code to make things work with a specific technology underneath. The way I do is I'll just go and change or swap with a JPA account repository instead of JDBC account repository. That's all configuration will be changed. So this is where you can actually easily change out the different implementation. I think somebody was asking a question.
Okay, Manjunath, and Amit here. So the question is, you told about that dependency injection, that if any class need any dependencies, all those dependencies are set before calling any of the functions or methods on it. And you also told about the order in which dependencies are set. So can you tell me once what do you mean by order? So
we'll talk about that later.
Okay.
I'll cover that anyways. Sure. Thanks for the asking question.
Sure. Yeah, no problem.
Sure. Okay. All right. So now we saw that the way swapping out can be done very easily by changing the configuration. Okay. But if you look at the way I do a changing from JDBC to Hibernate or JPA account repository, which is not something which I do on a daily basis or weekly basis or monthly basis. It's not a regular activity, right? Maybe once I take a decision to swap into a JPA, probably that will be an end. I won't be doing any more changes. It makes sense? So just for a changing or swapping out the different implementation, and why should I go and do and connect with an interface, write additional classes to inherit and do all those things? What I'm going to gain out of it by writing, except other than swapping out? Is there any real advantage for me? What other benefits I'm going to get when I do a swapping out or implement through a program to interface? Any thoughts? Yes. What is the real advantage I'm going to get out of this?
I think the reason that you told just previously, loose coupling and interface, creating the contract between two classes.
Right. I'm talking about in this specific scenario, when I build this loosely coupling, the only advantage what I get is swapping out the different implementation, right? This kind of swapping out, I don't think I'll be doing in regularly. just to swap out and getting a loose coupling, why should I unnecessarily go and invest additional time to write those additional service classes, interface classes, and bind the write additional configuration instruction to bind them together, assemble them together? Why I need to invest so much of time?
Will it be easier to manage afterwards compared to the old methods or the previous implementation?
Well, I can still manage even without having writing the interfaces. Maybe I can consider that manageability. I can still do it. Any other advantage?
So here we have more control on life cycle of this bean.
So what do I do with the life cycle of the bean? If I don't have an additional benefit,
To answer your question, so one of the example I can talk about is the repository module or the Spring Data module, where we just define the business use case, and the underlying implementation is actually taken by Spring itself, right? So the point, I mean, our responsibility is to define the business use cases, business functionalities, and the underlying implementation need not be made by us actually. It can be left out to Spring as well. So if we don't have an interface, we are actually bound to the implementation, and we will not be able to capitalize on what the underlying framework, in this case Spring, provides.
okay, got it. But let's say Spring right now, okay, Spring doesn't support any underlined features right now. Let's say, is there any other advantage am I getting here?
Um, uh, so basically, if I, okay, discounting that factor, then basically it is the advantage of interface which we are talking here. So we are
Correct.
not binding ourselves to an implementation, basically.
Okay, got it. So let's take a little more deeper look. Let's say I have a transfer service implementation. I have completed the implementation of business logic in the transfer service. Okay, and this JDBC or JPA account repository, some other team needs to write because it is related to repository, and many cases the same developer will be writing. Let's say I don't have an implementation of JPA or account repository, JPA account repository or JDBC account repository. So now the question is, how do I test this my implementation, which is a transfer service implementation? How do I test without having this implementation? Okay, so that's one use case where I wanted to test my business logic without even having those implementations. That is one thing. And irrespective of whether the implementations are available or not, okay, but I want to write a unit test case independent of my implementation where I want to go and stub something, okay, create some object, dummy object, fake object, and go ahead and do a testing of unit test of your piece of the code. Okay, so actually these interfaces will enable you to go and do that stubbing irrespective of those implementations are available or not, so that actually you can leverage doing a lot of testing of your code. Okay, the way it can be done is
So here we are talking about the advantage of Spring in terms of testability, right?
correct. So the way I can swap out, I can do a different implementation, which is like for a testing as well. Let's say I don't have a JDBC account repository or JPA account repository, and I have ready with my transfer service implementation business logic. I need to go and do a testing. Okay, in this case, I'll go and write this stub account repository, which is an implementation of account repository interface. I'll just go and create this object, and I'll put it inside this stub account repository for those methods which I wanted to test. I'll just go and put some fake data or dummy data. Let's say account A, whenever I ask for a 1, create one account object. Whenever I ask for 2, you go and create another object, or create a map of account objects written every time based on the key. Okay, so that logic I can go and write in stub account repository, and irrespective of anything else, I don't need a database server, I don't need an implementation of this account repository. I can just go ahead and test isolation manner. So that way, my business logic will be tested at the unit level. So this is possible, and this has been enabled by using this implementation, using the interfaces. Okay, that's an advantage. And that is why like this dependency injection gain a lot of popularity there, because in the way the EGB 1.x and 2.x was done, the testability for those classes which you will be writing, which is very difficult, that they address this issue in the EGB 3.0 though, but in the previous version it was very difficult to do a testing. Okay, so that's where like the testing part by doing a stubbing is gained a lot of popularity that time. Okay, so coming to an enterprise integration, so where we have let's say we have written the code where load account account 1, account 2, and debit and credit, and do a confirmation, update those accounts and confirm. If I wanted to put them together a unit of work, I need to make the complete my service code as a transactional code, either everything or none. If I want to make that as transactional, I need to go and put an additional code there in the transfer service implementation class, in the transfer method. Like say like I wanted to open the transaction and put that block of the business logic there, and finally commit or roll back if there is an exception. That's a kind of piece of the code I need to add it to in order to achieve this database transaction as an enterprise integration. Okay, if you wanted to do a security check, similarly I need to go and put a security check whether it has this permission or not, and if I want to do the sending a messages similarly. So all those things, like whatever I want to do an enterprise integration with a messaging or database or remote access caching, it requires some additional code to go and interleave with the business logic. Okay, so moment I add this additional code, there is a dependency on the transactional code, security code, messaging, remote, and caching, things like that. Okay, so that's an integration the way I integrate right now. But what Spring provides is Spring will helps you to integrate powerfully enterprise services into your application without even modifying your existing code. Okay, and keep your existing code as simple as that, and it is also testable, and you don't need to worry about those dependency to be injected. Okay, while having this, you can keep your code simple and also testable. Okay, that's one thing, and also plugs in into all Java Enterprise Edition application server. It can be tested in an standalone, or it can be tested in the application server. Okay, so Spring Enterprise integration will helps you to integrate this services powerfully in your applications with maintaining your code simple and testable as well. Okay, and coming to our testing, as we discussed, you can actually write a lot of unit test cases. At the same time, you can also make a lot of testing as an automated. So the way, if you implement your POJO classes, the way it is instructed or given recommendation by Spring, and that will actually enable you to write the unit test cases very clearly for each and every units. And that is actually decouples from your environment, so where you can plug in with the stubs and other things, and you can easily write your and test your quality of your unit piece of the code. Okay, and also Spring will help you to write the integration tests to test from the top to bottom, and it also provides something like scaled down versions of this additional third parties applications like database servers and message broker, things like that. So Spring will provide you those kind of scaled down version which you can run it in the same JVM, where you can run this integration testing system testing from the IDE itself. So that will help you to do a testing in a much better way also. So the way you can see the unit testing, so we use a JUnit test case, JUnit framework. They use all these constructs. I hope most of you are familiar with the JUnit framework. Okay, so we have this setup method. This setup method where it is annotated with the before, and this method gets executed before executing actually test method. So the test method is there like transfer money, which is attached with this annotation. Okay, before executing this method will get executed. So what you are doing here is you create a stub account repository as a repository account repository object, and inject this repository into transfer service implementation part of the constructor. So now your transfer service instance object is ready with an object initialized with a dependency injection is done. So now the dependency injection is done through constructor. Okay, so now we come and use this transfer service dot transfer and do the transfer of money from one account to another account. And in the account one, I have set up the $500. Okay, when I do a transfer of 300 from account one to account two, and what is left over in the balance of the account one is $200. So I'll go and confirm in the confirmation. I'll go and check the new balance. If it matches, I'll do an assert equal to this money. Then the test case must need to do an assert check. Otherwise, it's as good as not writing it. Yes. Anybody has questions? Okay. So this is the way you go and write a unit test case using a unit JUnit framework. Okay. This is the dependencies will be tested. Main method. This is the testing logic in the isolation measure unit design and implementation concreteness. Yes. Kiran, your voice is breaking.
Annotation, who is responsible for?
Can you come again?
Before check and then testing.
Okay.
Who is responsible for loading this checking?
Yeah, so still your voice is breaking, but if I understand your question in a correct way, who is responsible to add this annotation and where it is coming from? Is that right?
Yeah.
Okay, so it's this kind of test case will be written by the developer. Okay, a developer need to be aware of these annotations, and these annotations are coming from a JUnit framework. Did I answer your question?
Who is responsible for? Yeah, Manjunath, but who is responsible for loading this before? So it is only the asset classes.
When you say loading means what?
So when I start executing this unit test case, so it will start with the setup first and then the test cases. So who is doing this sequencing for this? So I mean, how the Spring loads this whole test classes together?
So this is a JUnit framework. JUnit framework is responsible to sequence it.
Okay. Thanks, got it. Yeah.
Okay. So coming back to the other component where accessing the data. So most of the enterprise application access the data store in a relational database. So one is you carry out the business functions or enforce the business rules. Okay, so there could be many resources you need to manage, and you need to connect with the different APIs, all those things. Okay, traditionally where you need to do, but the Spring Data Access provides makes data access easier to do effectively. So that means effectively means it manages the resources for you, so you don't need to worry about opening connection, closing connection, all those stuff. When you use the Spring resources, if the Spring is opening, a Spring is responsible to close it, and it manages the resources for you. So you don't need to worry about it. And also it provides some API helper class to make it simple to use. You don't need to worry about writing a lot of boilerplate code. That's another part of it. And the major part of the data access technologies, if you look at, I have many data access technologies like JDBC, Hibernate, JPA, MyBat, and a lot of other things. Okay, if I have to use the JDBC, I need to go and change the code, and a lot of my service code also gets impacted. So similarly, Hibernate and JPA. So what Spring provides is it provides a kind of abstractions. You don't need to worry about a service layer, and underneath you just need to go and change whether you wanted to use the JDBC or Hibernate or JPA kind of technologies. It is seamlessly like it creates workability from the application point of view. So also like exception part, JDBC throws the SQL exception, Hibernate throws the Hibernate exception, JPA throws the persistency exception, things like that. So your service layer code will come to know what kind of exception it is being thrown from the data access technology. So in order to abstract that, Spring comes up with an abstraction of all these technologies, and Spring itself throws one common exception, which is a data access exception. Underneath, all this exception will be converted back to data access exception and converts back and throws it to upper layer. So only Spring has to deal with the one specific exception, which is a data access exception. Okay, so kind of things being provided by Spring itself. Okay, and Spring also supports at the web layer. So one thing is Spring itself provides a web layer, which is a Spring Web MEC, and also it supports the Webflow, Spring Webflow. If you want to use the top to bottom as a Spring, you can go ahead and use the Spring MVC and Webflow to and backend with a Spring, core Spring, to create an enterprise application. That's one option. In many cases, like I have already existing web layer framework, and I wanted to continue with the existing framework, but the backend I want to go and design with a Spring framework. So in that case, you have a freedom to go and integrate the existing web layer with a Spring application context. Okay, so if you are using a Struts or JS of any other web layer framework, you can actually go and integrate. You can choose to do an integration with the existing framework, or go and use a Spring MEC at the web layer. So in the Spring MEC web layers, it will handles all the user actions, validate the inputs, and enforces the site navigation rules, manages the conversational states. And also it is responsible for rendering the responses, HTTP, HTML, JSON, things like that. In case of REST and other things, it supports a different kind of representation styles, and it also supports an Ajax. So again, the scope of the web layer discussion in this course is very essential, very limited. We'll be just talking about an introduction to a Spring MEC in this course, not on the details of it. So details of the Spring Web itself has a separate course, which is offers in a 4 days workshop, which is called a Spring Web.
Hello?
Yes.
There is a question. Yeah, we have other integration frameworks like prime faces and rich faces that we use. So how easy or difficult is it to be able to, plug in
I think
layers like that?
so. Spring Faces has been JSF has been provided. Integration is provided at the web layer. So you will be still implementing your web layer with a JSF Faces. Okay. And if the request comes to your JSF and you wanted to call the one of the object which is created using a Spring application context in the backend, that integration being supported by Spring.
I'm sorry, can you repeat that?
The integration between JSF and Spring backend will be done by Spring itself. There is a configuration for each and every web layer framework that has been supported.
Right. No, but the additional, the additions that I have to make to the configuration, if I have to use something like rich faces or prime faces.
That's all web technology, right? Not the web layer. Like it's like you're talking about the way you need to design your UI applications.
Yeah.
So that is nothing to do with a Spring. And if you are using a Spring MEC, okay, there is an integration provided by Spring at the different levels.
Okay. Okay.
Okay. Okay, and Spring also supports to develop this web services. You can do web services using a SOAP-based web services or RESTful services, and also integrating messaging infrastructure like JMS, and also like sending a messages from the different technologies that has been supported. And Spring also support this Spring security to serve the security services at the web application level, also at the different web services level. Okay, so that has been supported, and additionally, like a lot of other features being supported by Spring. There is a Spring integration and Spring Batch, there's a new there's a complete new projects to integrate enterprise integration itself. So that is like, I also have this tasks, how you can schedule a task, and there is a job scheduler when you wanted to schedule a job and see whether a job has passed or failed. If the failed next time, how we want to re-invoke all those things. All those things, functionality is being implemented in the Spring Batch. Again, like Spring Batch is not scope of this course. And to talk about this Spring Batch and integration, there's again a separate workshop which is like 4 days workshop of full time, that is a Spring integration, enterprise integration course. Okay, so if you look at all these features, it is not just like one thing, like Hibernate actually talks about only a ORM. If you look at the whole Spring portfolio, it's coming from the like bottom to top. So a lot of features, okay, being supported. It unless like a small portion of it. If you start using a Spring framework, you can develop everything using a Spring framework itself, like from security, web, backend, and lifecycle management, talking to the database, everything. Okay, so that is how the Spring has been created its profiles. Okay, and the history of the Spring framework, currently what we are going to discuss is about Spring 4, and the Spring 4 has a lot of other capabilities, but if you look at this whole thing, Spring 4.x and 3.x, and only a new additional features been added into each and every release. Okay, actually the core part has been solid and very reliable from Spring 2.5 onwards. Okay, so most of the things what we are going to discuss about the core framework is coming from the 2.5 core framework. Okay, and on top of that we'll be discussing about the new functions or features being added in the 3.x and 4.x. Okay, so we'll talk about the like environment profiles, cacheable, and also like how we can integrate RESTful services, Java configurations, all those things. We'll be talking about the new features for each and every release. And Spring has a very interesting history. Okay, the guy called Mr. Rod Johnson, actually he's a J2E architect. He has been developing an enterprise application. When he's developing an enterprise application, each and every problem what he encountered to solve in the enterprise application, building applications, he started creating a book, and he wrote a book out of it. Okay, all the problems. In the book, he also stated as solutions. Like this is the problem, how you can actually overcome with this solution for this problem. Okay, and he wrote the book called like book to solve this all the enterprise integration issues. Okay, so then he actually went ahead and implemented all those solutions in a framework, and that becomes the first framework, first version of the Spring framework. Okay, Spring 1.0 is evolved from the book. So a lot of framework, you go and write the framework, then the book will come out of it. But now interesting is like Spring has actually evolved from the book. Okay, so then the new it's been added a new enhancement over that. The 2.5 is becomes more reliable and started using that appropriate. That's about the Spring framework history. Okay, that's about why do we need a framework, and 2-3 different key concepts what we discussed is dependency injection, where the dependencies are get injected external to my code. I made it loose coupling. Okay, and the 4 different components what we discussed, the application configuration creation, and testing, enterprise integration, and data access. And other than this, like a lot of other capabilities being provided by Spring, which is like web layer, security, and Spring integration, batch, all this stuff. Okay, so this is about just a quick overview on what Spring is. Why do you need a Spring? Any questions so far? Okay, so